Hello developers, let's start developing. So today we're taking on the patch 12 of the 2023 Advent of Code. We finally got to the hot springs and it seems that the hot springs are quite literal hot springs that will move us away into the lava island from the gear island. So we have one more island that we need to do. So we need to fix the lava island, to fix the gear island, to fix the desert island, to fix the island, to fix the snow island, so that we can have snow. So the things we do to help Santa Claus. So we have some broken springs, so to say. These are the broken ones. The hashes and the dots are the functioning ones. And we have a list of springs, and after that we have another format when we write down the basically same information, and that's how many springs are in a row. So we have one broken and then one broken and then three broken. And similar here and here. But the problem is that, of course, they also are kind of weird. So they have lost a piece of their documentation. So they have no idea what's here. Basically, the problem is we need to reconstruct them. So there is just one way that this can occur. So if we want to have 113 for that row, we should have a hash and a dot and a hash. That's the only way. Because if it's dot hash hash, then we have 2 3. We don't have 113. However, for this scenario, we have multiple possible solutions. So dot hash will work, dot hash will work, dot hash dot will work, hash dot hash, and hash dot hash hash. Hash dot actually. So we have four possible configurations for this. And we have a lot of those things that can happen, and basically we need to count out all the possible arrangements and then sum them up. Sounds simple, and at first sight, this definitely feels like a breadth first search or something like that, where we will actually try to put a dot and see if it works, try to put a dash and see if it works, and we can get started basically. So let's see. The input, the demo input will be something like this. The huge input is a bit longer as always, but from what I've seen, it's not too complicated, especially since all the springs or the lines are independent. So we need to basically solve the problem on a single line. So let's copy over our small test case. Let's see. As always, we're gonna start by processing the input. So for our input, we're gonna have to have some types as I always do. So type spring will be either a dot or a hash or a question mark. And we will have our spring line, which is something like this type. Oh, I will call this a line, literally, unless we have some other word about that. Row. Yeah, we can call it a row. And we have the pattern, which is an array of springs. And we will have a list of numbers, which is groups, basically. So we need to find how many different actual patterns are actually doing the groups. So the good thing is that for this input and even for the bigger input, we we need to split them, and there is just one single space. So I will just split on a space. So yeah, we're gonna need to run a for loop. We need to map the lines actually. Since this, and we're gonna split on the lines on a space. We will need that, but after the fact. So we're gonna need, we have the springs and the numbers, and they are actually line split on a space. So we're getting the characters and then we're getting the numbers as well. And that's something like that. And then we're gonna split the springs on every character and map them as a spring. So this is our pattern. For the group, we're gonna take the numbers and just split on a comma and map them using parseInt with the base 10, because otherwise weird things happen. We return the pattern and the group, and we return result. So instead of using a string array, which we didn't use too much this time around, we're gonna have a row array. As always, once we're done parsing the input, we want to see it. Once more my computer is being sluggish. There is actually an Angular application being served here. Let's break that up. Anyway, let's see. We have our pattern, which is kind of looking like the test pattern. Let's see, maybe we have a straggler somewhere. Some weird test case that we didn't finish. Otherwise, we have 3 question marks, then a dot, then 3 dashes, and 113. Looks about right. And then we have the weird case with lots of dots. Okay, so now we will just do this. So input dot map. Actually, we can go input dot sum for each row. We can say get configurations count for that row. We can destructure it ourselves. And that's the result. And now we have the small issue of actually writing this function. Yeah, it's not that. That will just multiply all the groups together. That would have been nice, but it is wrong. So we're going to have return -1. So at the very least, this thing will be working. So now we will have to basically do a weird thing. What I want to do, I will find the first that and replace it with a this, find the first and replace it with a dot, count configurations now, count configurations now, return the sum of both. Something like that. So first of all, we need to find the first character, the first question mark. So yeah, we will pattern and groups. We will destructure this, and we will actually write another method that says const matches groups, where we will give a pattern and groups and return a boolean. So we will need to see whether a pattern matches certain groups. So we will need to see, we will need to actually count each group of hashes. So we will need have something like this, and we will need to say, yes, this thing matches. Or if we have something like this, we will have to say this thing doesn't match. Okay. And I would like to basically return as early as possible. So this means, let's say something like this. Let p index, that's the index, and the pattern is 0. And the index of groups is 0. I'm gonna do an endless loop here. Actually, we can say, well, p index is less than pattern dot length, and group index is less than pattern groups.length. So continue looping until you get to until you run out of everything. So let's have another thing. We're gonna say I want something that will remember how many hashtags we encountered so far. I'm gonna just call it that hash count. So we're just gonna say if, and we definitely can have a current group. We don't need, so groups are basically regular arrays of numbers. We don't need to do anything, any processing for that. Is groups of G index. So if the pattern of P index is a hash, then we increase the hash count, which means that we have found a hash, and now we increase the hash count. And we can just have a few conditions that we say. So if the hash count is bigger than the current group, this is not a match. And we can even put it here. Because we have two distinct possibilities, that we have that and that and that. So after actually here we know that the pattern of p index is a dot. So I will have something more a bit complicated. So if we get to a question mark, this thing that this is actually unknown because we have a question mark. We don't know the pattern. So actually in this case, I will say we are returning not false, we are returning a null. So we will have a 3 valued function. This will return a boolean or a null. And of course it doesn't. So we will say here return. So we need to find all the possible ways that it doesn't match. So if we have a question mark somewhere, we're going to return a null, which means that so far everything went great, but right now we just don't know. Makes sense. But we don't want to do this too early, because if we have a question mark at the end, we might have some situation at the beginning of the pattern that will be invalid. And for those, we want to say, yeah, this is invalid. So if we get a question mark, it's that. And if we get a dot, like here, this is a dot, we should be, yeah, we can do something like that. So if we have a dot, we need to do this. Are we satisfying the current group? Because we might have more dashes and we might have less dashes. So we are getting a dot. And I will add another condition here, because we can just skip the initial dots. While pattern of p-index is a dot, increase p-index. So right now our p-index is at the first non-dot character, because that's the only thing that interests us. If it run away, if it, oh, and now we will need to see, I will add some more code here. So if the next one is a dash, yeah, this will actually work, but it's not what I'm interested. But I will say if we run out of, is this a possibility that we have all of the old dots? Well, doesn't hurt to check. So if width is equal to the length, which means that we run out of dots because we run out of pattern, then basically that is correct if we have our groups is an empty array with no groups, otherwise it's false. This should never get executed, but let's be sure, because right now we know that we are inside the group, we're inside the pattern, and we need to continue. So if the pattern of p-index is a dash, then we just need to check add it. We're not moving to the next group, we're not doing anything, so we can just say continue here. With one other things, we need to increase the p-index. So we are exiting out of both these ifs, so this is actually a dot. If we finished our current group, we're gonna increase the g-index, we're gonna of course increase the p-index as well. So I had a think, and fortunately I came up with another solution that might enable us to brute force this. And if you know one thing about me is that I love being able to brute force things, which means that sometimes it's maybe better to write code that is simpler and less effective and less elegant, but easier to understand and just as operational. So we should not try to find the most elegant solution to a problem because that can be time consuming, that can lead to some code that is hard to understand, especially for younger people. So don't try to be too clever and write code that's too clever, but code that is clear and where we can find the bugs. I'm quite sure that this pattern matches group is quite good code, but quite efficient code, but it will be hard to understand, it will be hard to debug, and I have a feeling that I already have a couple of bugs in there because we have too many moving parts that we need to take care of. But let's take a different approach. But first of for that, I would like to actually check out the huge input. What is the maximum number of question marks that we have? If it's under 20-ish, under 15-ish, I would say, we have 1,000 of those. So, for example, on the last one, it's quite obvious what an elegant solution will be. Just from looking at it, we know that we have that the first question mark has to be a dot in order to fulfill the 3. 4 has to be a hash, actually. And this one has to be a dot. Otherwise, we don't have 3, 4. So now we have the situation when we have 1, 2, 3, 4, 5, 6 question marks. And exactly 4 of them needs to be in a line of hashes. So that means for that option, we have hash, 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 dot, dot. And then we have dot, hash, 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 dot, or even dot, dot, hash, 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 hash. So this is actually giving us 3 options. That's good. But let's get back to the brute force. Let's check how many question marks we have. So input dot patterns dot map. For each row, we're gonna take the row patterns dot filter. If something is a question mark, and then get the length. This is the Q marks, and I will just group them. I will use group reduce. So the key selector for each number, this is just an array of numbers. Well, it's a number. For each number, just take the number. We're gonna have a reducer that's just counting, and that's it. And this is a histogram. So log the histogram. Let's see what we get when we do log the histogram. And we're doing this for the big input. Most likely for the second part, we will have to do something more elegant because it will be an extension of the problem that is bigger. And here is our result. It seems that we have quite a lot of 17s and 18s and 15s and 16s. So I said that I will say that anything above under 20 is Okay, so it is at the lower end of feasibility, but let's just try it. If it works, it works. What I want to do is basically do something along these lines. So I will generate all the possible elements, all the possible options, and if we have 20 options, we have about a million possibilities. For 18 options, which is the current maximum that I'm seeing, I'm not seeing 19 anywhere, we will have about 200,000 options to verify. And we can make some code that just verifies if this works. So this is the one with the question marks, but let's just write another method that will be much simpler, that will actually give us a proper boolean, and which can be quite simpler. Actually, let's not do that. Yeah, we can keep this part. We just don't want this part. Or we can have this simple and inefficient. So what I will say, I will just try to regenerate the groups from the pattern. Something like this. Not group reduce by, but just reduce. Or since this is reduce is basically a for loop, we can just use a for loop. Yeah, we have our hash count, and if the character is a hash, then we increase the hash count and we continue. And if the character is a dot, then we don't continue because that's the only other option. What we will do? Well, if the hash count is bigger than 0, we say that we just finished the group. And we just need that thing once more. And now we have our pattern groups. Does this thing exist? Actually, now this thing hallucinated, and it says if you have this many helper methods, you probably have this one. And I actually don't have this one. But I will just say if pattern groups is not equal to the length of the pattern groups is not equal to the group length, then we return false. Otherwise, we check piecewise, and if something is not the same, we return false. Otherwise, we return true. So this will check whether a pattern actually has that group. Now, for get configuration count, I won't do this. I will say generate all the possible patterns. Not qmark index, but qmark count. And that's this. And this is this many options. We have this many options. Since I will return to the small input, since we have yeah, it's smaller, so we can do some debugging. I will have some issues. I will just do a for loop. Index is from 0, it's less than options count, and we don't need any elements, we need to generate a pattern. And I will also do something like this. Let's create an array with these. This is a great guess from Copilot. You mark indexes. So we are mapping, if it's a question mark, it's I, otherwise it's -1, so filter them all. So I will get an array of indexes of question marks. So I have an array of, for this input, I will have an array that says 0, 1, 2. Here it will have an array that says 1, 2, 5, and 6, and whichever this is. So now I will actually need to replace those things. So we need to generate all the possible options. How do we do that? Well, we have a number here that's indexed, and we can always check whether it's compatible with that number. So for it, what I will do is that I have the number, let's say we have the number 11, and we have question marks, 4 question marks. 1, 2, 3, 4. 11 in binary is actually, that's 8 and 0 and 2 and 1. Because that's 8 and 2 and 1. So we say this is a 1, so you get a dot. This is a 0, you get a hash. This is a 0, you get a 1, that you get a dot. This is a 1, you get a dot. So all possible options. How do we change the index to a binary? Well, we do it this way. This is where transferring it to a binary string. Again, something that's not efficient, but it's quite easy to do. That is the binary. And now we can take a copy of the old pattern, and we're gonna do something like this. For each of the Q's of the question mark that we will take that index and look it up in the new pattern. So this is a question mark right now. And I will say, if that corresponding element is a 0, then return a dot, otherwise return a hash, because the bindex will only have zeros and ones. And now I can say whether the pattern matches group, the new pattern and the old group. This is a boolean, and if this is true, well, yeah, we will do that, but we also need a count, which means that we will need to actually increase the count, and here return the count. So we're generating all of those options. So for this we will generate 8 options, for this we will generate to the 5th 8, 16, 32 options, for this we will generate a bit more, and so on and so forth. And let's see if we get something. And let's see if the code that we are actually running makes any sense. Yeah, we don't need the histogram right now. From our initial analysis, it's obvious that we don't need to check a lot of partitions, that a lot of the partitions don't make any sense. But let's see. And the results are we can see that we just didn't match anything, which means that we have some kind of a bug over here. Let's debug this. It should automatically attach. Eventually, and we're here. So the pattern we have is the first one. So the Q count is 3. The options count is 8. That makes sense. The Q mark indices are 0, 1, 2. We have their count. This is up to 8. So the bindex should be 0, 0, 0. Yep. The new pattern is a copy of that, and for each of our new patterns we need to change that and that and that. So we should get a pattern that actually has 3 dots. The new pattern should be dot 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 and everything else. So that means that we have a bug in our pattern matches group. So let's see. Hash count is 0. So let's run it until here and see what we get. So we have our pattern group. We should have as one group of length 3. Yep, that is correct. And it should return false. So for the next one, our pattern should be a dot dot hash. Dot dot hash. So we have one group and 3 groups. So the pattern groups are 1 and 4. Oh, that is wrong. How do we get that? I totally know how do we get that, because if we push the hash count, we need to reset it. Let's try it once more, see if we get this, because it turned out that our hash count was actually a cumulative value. And we got some results. Let's see. For the first one, it says this is a solution. And let's go back for a bit on the explanation to see what it said. So the second one should have 4 arrangements for this. Let's see if we have. So we have, yeah, we have dot dash, dot dash, dot dash, dot hash, hash dot. And then we have hash dot dot hash and hash dot hash, hash dot. Yeah, those are the 4 things that we actually want and need. So seems that this is kind of working. Let's try it on the big input, and I will actually log the console count here. but omit this one. We don't want to see all the new patterns. We just need to see the results for that. Run this once more. Yeah, the results are in, and we needed to get 14111410, and we got that. So this means that this part is functional. I will add one more thing to this. I will add a second parameter that says here index, because I will like to know how far we got. Not index, but ID. Let's call it ID. This is the ID of the case, and here we have case ID has count configurations. We will change over to the big input, and let's see if this works and how fast will it work. We had situations with up to 4 or 5 question marks so far. It's gonna be a bit trickier for 18 because those are 200,000 options, but let's see. My computer is being sluggish today, but anyway, it shouldn't be too long. So we're processing the cases, getting configurations, and I'm quite sure some of these had some hundreds of thousands of configurations, but we're kind of halfway there, 40%. So once more, this is extremely inefficient, but still even that can provide us with relatively satisfying results. So if the result is under 1 minute or something like that, and it's 41 seconds, I'm quite okay with that. Especially if that result is correct, which we will see now. And that result is correct. No reason to be incorrect, because one thing that brute force kind of gives you is that if it works, you're kind of sure of the result. Because there's just no trickery involved here. It's just brute force. We are just generating all the possible conditions. We are checking all the possible configuration, and we're counting the ones that fit. It's not an issue. But I'm quite sure that part 2 will actually mess this up for us. Way more string than the conditions list. They were actually folded up. To unfold, replace the list of string conditions with 5 copies of itself replaced by a question mark, and replace the list of continuous group with 5 copies of itself separated by a comma. So this row becomes this row. The first line above the example would become this row. And this is the problem, because now the one that we had 18 question marks actually has 1, 2, 3, 4. The one where we had 18 question marks, right now we have some more question marks, because we will have times 4 times 5. 5 copies, and then we need to add 4 for the ones that are separating. So it has 94, which means that we will have to actually do 1 to the 94th power, which doesn't look that big, but this is the wrong thing, because we need matpow to 94, and this is the correct value because we cannot shift bits on something that if we shift too many bits, basically we wrap around because we are limited to 64 bits or 50 something in JavaScript, but this is a huge number. So our brute force will stop working. So brute force worked fine up to a point. We don't need to brute force the brute force. We're not gonna push it in any external direction. So this means that for the second part, we actually need to do the proper analysis and see what the logic is and how we can change it and see if we can optimize it optimize it greatly. But the good thing when you start with brute force is that now I have a baseline. I know that this algorithm works. So for any optimization, I can compare the result from that optimization with this result. If it gives me the same results, that means that my new and improved algorithm is correct. And I can never fall below the baseline. And that's a great thing. So with brute force, if it works in a reasonable time frame, that means we have solved the task. And if it doesn't work in a reasonable time frame, that means that we have a reasonably coded baseline. So in part 2 of this video, we will continue actually implementing the nice and elegant solution, but comparing it all the time with the solution from the brute force. So bye for now and keep developing.